students, we are going to do chapter 3 of chemistry, chemical formulae and equations. This chapter, guys, is very important. Okay, this chapter is all about calculations, so we need to understand how these calculations work. Now I've got an interesting way of doing it, so don't worry about it. Just listen to everything I say, follow my steps, and we'll be good to go. Okay, all right, let's start. Now for this chapter we have a few definitions. I'm just gonna mention them very quickly, don't have to go into them in depth. Okay, the first thing is called relative atomic mass. Relative atomic mass. Now I'm going to read out the definition to you guys. Write this down and then I'll explain what it is. Okay, so the relative atomic mass is the mass of an atom when compared to the mass of carbon 12. Yes, exactly, carbon 12. So what this means is we are comparing the mass of an atom to the mass of carbon 12. Why are we talking about carbon 12? We'll come to that in a second. The second definition is relative molecular mass. Now, relative molecular mass is the mass of a molecule compared to the mass of an atom of carbon 12. Okay, so again, we're comparing the mass of a molecule to the mass of carbon 12. Now, I know you guys are wondering, why are we talking about carbon 12? Remember, students, that carbon has an isomer. In the periodic table, carbon has a nuclear number of 12. Remember, sorry about that, C612, right? And we said that carbon has two isomers, C613 and C614. Now the carbon that we are talking about is this one, carbon 12. The reason why we compare the mass to carbon 12 is one of the most stable elements. Okay, so let me just write that down, C12, one of the most stable elements. Now you don't have to memorize the definition of relative atomic mass and relative molecular mass. I think it's good to know why we compare it to C12. So if you see a question, why do you use C12? You can say because C12 is one of the most stable elements. Okay, now that's it, students. I'm going to go straight into calculation. For this part of the session, what we're going to do is, since the questions are long and it's kind of hard to write, I will read out the question very slowly. I will pause and I want you guys to try to understand the question. Just pause the video after writing down the question, look at it, and then unpause and we start to solve. Okay, so the first question I'd like to give you is, how many times larger is the mass of a magnesium atom compared to that of a helium atom? So we have a magnesium atom, which is magnesium is Mg. We have a helium atom, He. Now students, before we even solve this question, remember this topic is all about mass. Now mass number is the same thing as nucleon number. Okay, in chemistry we call mass number nucleon number. So we are only dealing with the number on top of the element, the nucleon number. This has nothing to do with the proton number. Okay, so how many times larger is the mass of a magnesium atom compared to that of a helium atom? What is the mass of a magnesium atom? If we look at the periodic table, the nuclear number of magnesium is 24. What is the nuclear number of helium? It is 4. So we already know it. Logically, the number of magnesium atoms is 6 times larger than the number of helium atoms, right? Simply because 24 divided by 4 equals to 6. Does that make sense, students? If I said, for example, how many times larger is the number of silicon atoms compared to the number of lithium atoms? So, silicon has a nuclear number of 28, and lithium has a nuclear number of 7. So, the number of times silicon atom is greater than the mass of lithium would be 28 divided by 7, which is equals to 4. This is the first type of question. Now, these kind of questions won't come out on the exam. This is just to build your understanding. So, bear with me, we're going to build up, okay guys? Next example. Calculate how many times larger is the mass of 4 carbon atoms compared to that of 3 helium atoms. Okay, so pause, write the question down, and then let's think about it, and then let's look at it. So, 4 carbon atoms and 3 helium atoms. And they are asking for the mass. How many times greater is the mass? What is the nuclear number of carbon? 12. So, we have, this is the nuclear number for 1 carbon atom. What will it be for 4 carbon atoms? 12 times 4, which is 48. What is the mass number of helium, or the nuclear number? Helium 4. This is the mass for 1 atom of helium. What about 3 atoms of helium? It would be 4 times 3, which is 12. So, what does the question want? Calculate how many times larger is the mass of 4 carbon atoms compared to that of 3 helium atoms. Same thing, 4 carbon atoms will be greater than 3 helium atoms by 12 divided by 12 equals to 4 times. You see the logic, guys? We're building, we're getting there. Keep at this, we're going to get through to this, and we're going to make an A in chemistry. Next, how many magnesium atoms have the same mass as 2 silver atoms? Now, so let me just write down magnesium and silver. Now, the symbol for silver is Ag. How many magnesium atoms have the same mass as 2 silver atoms? The mass of magnesium, if you look at the periodic table, remember mass is nuclear number, so 24. For silver, it is 108. But the question says, how many magnesium atoms have the same mass as 2 silver atoms? This is the mass of 1 silver atom. What is the mass of 2 silver atoms? 108 times 2, which is 216. So, 2 silver atoms is how many times bigger than 1 atom of magnesium? Same thing, 216 divided by 24, which equals to 9 times, or 9 atoms, sorry. You can also just leave the answer as 9 and you'll be good. So, does this make sense, guys? Are you able to understand this? Good. Now, what we did just now was just individual elements, individual atoms. Now, what if we do compounds, which combines 2 elements? How do I find the relative molecular mass? Now, notice I'm using the word molecular mass because we're talking about a compound. If I give you, for example, H2O, how do I find the molecular mass of this? Simple, guys. How many H's do we have? We have 2 H's. How many oxygens do we have? We have 1. So add the mass of the 2 hydrogen atoms and the 1 oxygen atom, and remember, this is mass. What is the mass of hydrogen? 1. What is the mass of oxygen? 16. So relative molecular mass is 2 because of this 2 over here, multiplied by 1, which is the nuclear number, plus the nuclear number or the mass of oxygen, which is 16, gives us 18. This is how we find relative molecular mass for a compound. Okay. So question: calculate the relative molecular mass of carbon dioxide, and the question has given us the relative atomic mass of carbon is 12, the relative atomic mass of oxygen is 16. So what is carbon dioxide? CO2. We know that carbon's mass is 12, oxygen's mass is 16. So to find the relative molecular mass, the mass of carbon, which is 12, plus we have 2 oxygens, so put a 2 out here, open bracket, multiplied with the number of or the mass of oxygen. So 12 plus 32, because 2 times 16 is 32, equals to 44. That's the molecular mass of carbon dioxide. Let's do a few more examples to build up your confidence, students. Molecular mass of hydrogen. Now hydrogen is a gas, so it's going to be H2. Molecular mass of oxygen. Molecular mass, let's do one more, ammonia, NH3. So hydrogen's nuclear number is 1, so the molecular mass is 2 times 1, which is 2. For oxygen, the mass number is 16, right? So to find the molecular mass, 2 times 16, which is 32. And for the last one, ammonia, we have the mass of nitrogen, which is 14, and we know the mass of hydrogen is 1. Sorry about that, it's 1, not 3. So to find the molecular mass, the mass of nitrogen, which is 14, plus we have 3 hydrogens, so put 3 there, open bracket, mass of hydrogen is 1. 14 plus 3 is 17. This is how you find relative molecular mass, students. Isn't it easy? Yes. We'll do one last one, a little complicated one. Not too complicated, but it's a bigger formula, but same principle, okay? I'll read out the question, write it down. You guys try first, pause the video and check if you get the same thing as me, okay? Let's go. Calculate the relative formula mass of sodium hydroxide. So, what is sodium hydroxide? NaOH. But wait a second, didn't I say relative formula mass? We never talked about relative formula mass. We only talked about relative atomic mass and relative molecular mass. So what could relative formula mass mean? Don't worry, students, relative formula mass and relative molecular mass are the same thing. So we have 3 elements in this compound. We have sodium, whose mass is 23. We have oxygen, whose mass is 16, and hydrogen, whose mass is 1. So to find the formula mass, 23 plus 16 plus 1. 23 plus 16 is 39, 39 plus 1 is 40. There you go, relative formula mass, relative molecular mass. It's that simple, guys. Now, slightly more tricky questions which involve a bit of understanding, but the same principle, okay? We're just going to keep doing examples. So write this down, students. The relative formula mass of a compound with the formula Y3P4 is 205. Calculate the relative mass of element Y, and they've given us the atomic mass of P to be 31. So let's think about this for a second. I said the formula mass of Y3P4 equals to 205, correct? Now, how do we get this 205? We back calculate. 3, because of the number here, times the mass of Y plus 4 times the mass of P, and we know the mass of P is 31, equals to 205. Can we find the mass of Y? Obviously, the relative atomic mass, sorry, just math. So 3Y plus, what is 31 times 4? 124 equals to 205. So 3Y equals to 205 minus 124, which is, let's see, 5 minus 4, 1, 10 minus 2, 8, 81. So Y equals to 81 divided by 3, which is 27. Make sense, guys? This is the relative atomic mass of element Y. It was a back calculation, but we used the same concept. I hope you guys really understand this question, okay? Now, SPM clone question. Wow, clone question. This should be interesting. Write this down, guys. A compound with a formula X2CO3, X2CO3 has a relative formula mass of 106. Okay. What is the relative atomic mass of X? They gave us the atomic mass of C and O. C's mass is 12, O's mass is 16. Same thing, 2X plus, what is the relative atomic mass of C? 12. What is the relative of O? 16 times 3 equals to 106. Basic math. 2X plus, this is 48. 48 plus 12 is 60 equals to 106. So 2X equals to 106 minus 60, which is 46. X equals to 23. This is the relative atomic mass of X. So guys, how do you feel about this? Are you confused? Is it too much? Go over this, try to understand this. Let me know if there are any questions. Just write a comment and I'll be more than happy to help you out. In the next section, we're going to talk about mole, which is a very big concept. So make sure you understand this and stay tuned. Thank you, students.